Hi everyone, welcome to our next video. This one is going to be starting chapter 4, so we're going to be in 4.1 today. Let me go ahead and start writing in the notes. So 4.1 is inverse trig functions. So inverse trig functions. We actually did cover inverse trig functions in what section was that? 1.5. 1.5. We did them like in the very beginning, and it was basically talking about what if you're looking for an angle. You would use an inverse trig function. The only thing is that in 1.5, we only talk about them in reference to quadrant 1, whereas now we're going to talk about them wherever. So I'm going to write some stuff down for you. So remember that if something's in the form y equals sine alpha, for instance, the inverse trig function would say alpha is equal to sine inverse of y. So y would be like the point on the unit circle, and then alpha is like your angle in this instance. You could also see it written as arcsine. So sine inverse or arcsine are meaning the same thing. You could also see this with cosine. Inverse is the same as saying arc cosine. You could do it for tangent. You can do it for any of the trig functions. And we will look at the other ones as well later, but right now I'm just kind of writing the notation for you. Also, something to know about inverse functions is that functions must be one-to-one to be invertible. Oh, let me put myself on Do Not Disturb while I'm doing this video. Now, I'm not sure if you really remember what it means to be one-to-one. It's more of an algebra topic of when like that is covered. To be one-to-one, you must pass the horizontal line test. Basically, what has to happen is one x value has to match one y value and vice versa. So for instance, x squared is not a one-to-one function because if you look at the shape of it, it looks like a parabola. It doesn't pass the horizontal line test. And then also you're having like two different x values go to the same y value. So it's not like a one-to-one in the x's and y's. So for a function to be invertible, it has to be one-to-one. Now the issue is our trig functions are not one-to-one if you look at the whole thing. So let me remind you what sine looks like. So we'll have 0, pi over 2, pi, 3 pi over 2, and 2 pi. Over here, I'm actually going to write negative pi over 2 as well. And so at 0, sine is also 0. Sine of pi over 2 is going to be positive 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. Sine of 2 pi is 0. And if we go over here, negative pi over 2 is the same as 3 pi over 2, so negative 1. Try to draw these as best as I can. So here's kind of what the graph of sine is looking like. And so often when we were graphing, we only really looked at this half of it, and that's fine. I just showed you a little bit extra, and there'll be a reason for that. Something I want to point out, I'm trying to get rid of that green line. Okay, there we go. Something I do want to point out is that if you look at how this is graphed, so 0 to pi over 2 is quadrant 1. Then pi over 2 to pi is quadrant 2. Then we're in quadrant 3. Then we're in quadrant 4. So as you look at the graph, you're like in each quadrant. This one is quadrant 4. So the issue is that right now, sine is not one-to-one, right? I can put a horizontal line and I touch more than one point at a time, so not one-to-one. However, we can do something called restricting the domain, which basically means we can say, okay, what if we restrict our x values between a certain interval? Then can we force it to be one-to-one in that interval? And so what we're going to try to do is we're going to try to section off a portion so that we can get all the positive and negative values of sine, and then we don't have any repeats, like we won't have any places where it fails the horizontal line test. So I'll let you know the interval that we're going to pick is going to be from negative pi over 2 to pi over 2. Technically, pi over 2 to 3 pi over 2 could also work because it shows all the values of sine. So you got the negative and the positive, and then you don't have, like, it passes the horizontal line test. You can draw a horizontal line. The issue with picking that one is that it doesn't include quadrant 1. And what we will find is that we're going to have to section off for cosine, for tangent, we're going to have to section all of them off. And it'll just be really nice if we can include quadrant 1 for all of them. So let me write down for you what this means. So y equals sine of x is invertible on the domain or the interval negative pi over 2 to pi over 2. So if you're looking at the quadrant this way, how we often see it, we're going to be looking at quadrant 4 and quadrant 1. And we are able to include this piece and the piece up here. So we include all of that. What this means, so alpha equals sine inverse of y. Alpha must be in the interval negative pi over 2 to pi over 2, which we will find is going to be quadrants 1 and quadrants 4, also including the quadrantals of negative pi over 2 and pi over 2. So let me show you an example to kind of show you how this is going to be used, and hopefully it'll make a little bit more sense. So example 1, I'm just going to say evaluate. And we'll do a few of these. So now instead of, right, so usually before I would give you an angle and then like you would look at the table or something like that and you would give me the exact value that matches it. Now we're basically doing the opposite. So for our first one, let's look at sine inverse. We'll do a half. Part B, let's do sine inverse -1. Part C, let's do arc sine negative √3/2. And I may make up another one as well, but we'll start with these. So for sine inverse 1/2, what I'm looking for is I'm pretty much looking for what angle would I plug into sine so that it would equal 1/2. So off to the side here, I'm going to rewrite that table that we use very often. So sine, cosine, 30, 45, 60. So this is 1/2, 2/2, √3/2. This is √3/2, √2/2, 1/2. So right now we're looking for the angle. So we're saying, okay, we're looking at sine 1/2. So what angle makes that happen? And in this case, it would be 30 degrees. So this equals 30 degrees. If you want to put it in radians, that would be pi/6. Now the other thing to keep in mind is that our answers are only supposed to be from the interval -pi/2 to pi/2. So that's basically 90 and, well, negative 90 and 90. So it means we're only looking at quadrant 1 and quadrant 4. Since it was positive here, that's why we ended up in quadrant 1. So let's go ahead and look at part B. Part B says sine inverse -1. So I'm looking for the angle that makes sine -1. So for this one, I actually want to pull out the quadrantal angles. So this is the point 1, 0. This is the point 0, 1. This is the point 0, -1. This is 0 degrees, 90 degrees, 270 degrees. And so we're looking for where sine is -1. Remember that sine is the y value, so that's happening down here at 270 degrees. So we would say equals 270 degrees. In radians, that would be 3 pi/2. And I don't really mind if you write your answer in degrees or radians. I'm just writing both for you so that you have it in the notes. I'm not really picky. The online homework may be kind of picky, so just watch what they ask for. I'm going to bring my C down here because I don't want to lose the table or anything. So this one asks arc sine -√3/2. So this negative is actually going to tell me what quadrant I should be in. So sine is positive in quadrant 1. It's negative in quadrant 4. So that means that my answer right here has to be in quadrant 4. Now, it is true that sine is also negative in quadrant 3. However, quadrant 3 is not in that range, like interval that we've set up. So that's why we don't want to include anything in quadrant 2 or anything in quadrant 3. It should either be quadrant 1 or quadrant 4. If it's positive, quadrant 1, negative, quadrant 4. But then if I go look at my table, so if I look at sine √3/2, that's happening at 60 degrees. So that means that my reference here is 60 degrees. So I'm looking for the angle in quadrant 4 that has a reference of 60 degrees. And so if this is 0 or 360, I'd do 360 minus 60, which gives me 300. So this answer would be 300 degrees. If you would like to do it in radians, this would be pi over 3. This would be 0 or 2 pi, which can be written as 6 pi over 3. This would be pi over 3. 6 pi over 3 minus pi over 3 would be 5 pi over 3. So the radians answer would be 5 pi over 3. So you just have to make sure that while you do sine, your answer is either in quadrant 1 or quadrant 4, or it can also be 0, 90, or 270. And that's all because of that interval that we've set up. Now I'll do some more of these as we go on, but next I'm going to talk about cosine. Because cosine will also need to have a restricted domain. So the original graph of cosine, so 0, pi over 2, pi, 3 pi over 2, and 2 pi. So cosine of 0 is 1, cosine pi over 2 is 0, cosine pi is -1, back to 0, back to 1. So here's what the graph looks like for cosine. So again, as it is, we do not pass the horizontal line test. So what we have to do is restrict our domain, restrict our angles. So for this one, we still want to include quadrant 1, which I'll remind you is right here on the graph. So for this one, in order to get all of our values of positive and negative cosine, I'm going to go ahead and restrict from 0 to pi. So just like I did before, let me go ahead and write out what this means for us. So y equals cosine x or you can put alpha if you want, or you can put x, whatever makes more sense to you. I'll go ahead and put alpha. Up here, I do notice that I wrote x here in the sign, and then I wrote alpha at the bottom. In this case, my x is my angle, so I kind of wrote those interchangeably. So y equals cosine alpha is invertible on the domain, or interval if domain scares you, 0 to pi. So what this means is that alpha equals cosine inverse of some value. I want to write it how I wrote it up here. Alpha must be in the interval 0 to pi, which is going to mean that we're looking at quadrant 1 and quadrant 2 here. If it helps to look at it this way, we're basically looking at the top. And we are including 0 and pi in. So again, we're going to do some problems. So example 2, I'll just say evaluate the following. Sometimes the online homework will say find exact value. I don't love saying that because I feel like that kind of messes people up, that they're supposed to find an angle. So just be careful. So let's look at, we'll do cosine inverse 0. We'll do cosine inverse negative root 2 over 2. We'll do arc cosine, because remember I can either say cosine inverse or arc cosine. This one, let's do root 3 over 2. And then I'll do one more. We'll do cosine inverse 1. So again, I'm always kind of going back to either the table or like the little setup that I use for the unit circle. So I'm going to go ahead and copy and paste this little table and everything with us so that I can reference back to it in front of y'all. Hello. There we go. Well, I want it to move over to where it's more usable. Okay, there we go. Okay, so if we look at cosine inverse of 0, here, let me write the other side over here on there. That way, because now I actually want to include that side, so there we go. So cosine of 0, technically it happens in 2 spots. It happens here. Oh, be careful, not the y value. It happens here and here. So cosine is technically 0 in 2 different places. And that's true for negative root 2 over 2 as well. Like it's negative in 2 spots. But the interval restriction makes it to where there's only one answer. Remember, because it has to be from 0 to 180. So that's only including quadrant 1 through quadrant 2. So this answer is going to be 90 degrees. In radians, you would say pi over 2. And I'm not really picky. You can do whatever. Radians or degrees. So we should only ever get one answer for the inverses. Now let's go over to part B, cosine inverse negative root 2 over 2. The negative is what determines my quadrant. So cosine is positive in quadrant 1. It's negative in quadrant 2. So this means that my answer needs to be in quadrant 2. But the root 2 over 2, if I come to my table, it says that my reference is 45 degrees. So what I'm looking for is I'm looking for the angle in quadrant 2 that has a reference of 45 degrees. So I would do 180 minus 45, so I get 135 degrees for this one. The radians answer would be 3 pi over 4. I know that because pi is the same as 4 pi over 4. Subtract pi over 4, so I get 3 pi over 4. Part C, we'll do arc cosine square root 3 over 2. So this one's positive. So that tells me that my answer is going to be in quadrant 1. If I go look at my table, it looks like my reference is 30 degrees. So that means that I'm looking for the angle in quadrant 1, reference 30 degrees. So just 30 degrees. In radians, that would be pi over 6. And then for the last one, I'm looking for the angle in which cosine is equal to 1. So if I come to my chart over here, remember cosine is the x value. So I'm seeing that happen at 0 degrees. And in radians, that's still just 0. So there you go. We did some cosine ones. I hope these are getting a little bit better as we do more. You just have to keep in mind like which intervals for which functions. Next, we're going to look at tangent. So the normal graph of tangent that we look at, so pi over 2, pi, 3 pi over 2, 2 pi, 1, negative 1. That looks all right. So pi over 2 and 3 pi over 2 are actually asymptotes. This one you're going to find that we're going to use negative pi over 2 as well, and that is another asymptote. So here's what my graph is looking like. They're just supposed to be the same thickness. It's just a sketch. The cool thing about tangent is it actually breaks it up for you. So the interval that we're going to use in order to preserve quadrant 1, just like we did with sine and cosine, we're going to block it off at negative pi over 2 to pi over 2. However, we have to be careful here because we can't actually equal those. So tangent alpha is invertible on the domain. This one is negative pi over 2 to pi over 2, but you'll notice that I'm using parentheses instead of brackets. And it's because these really need to be dotted lines because it can't actually equal those angles because it's undefined at those places. So this means that for alpha equals tangent inverse of some value, alpha must be in the interval negative pi over 2 to pi over 2. So very similar to sine, it's just you have to use parentheses instead of brackets. So again, this is going to be quadrant 1 and quadrant 4. So we're going to find tangent is positive in quadrant 1, so that's where we're going to get our positive ones. And then it's negative in quadrant 4, so that's where we'll see like if we want something negative, we would want an angle in quadrant 4. So of course, let me do an example. I'm just going to say evaluate. And let's do tangent inverse 1 over root 3. We'll do tangent inverse 0. And one more. Let's do arctan. I like to write them differently depending. Negative 1. So again, I'm going to keep my table and everything that I use, so I'm just going to redraw them this time. So I have 1, 0, 0, 1, negative 1, 0, 0, negative 1. This is 3 pi over 2, 0, pi over 2, or pi. And whether you want radians or degrees is up to you. Sine, cosine. Now because I'm dealing with tangent, I may want to add tangent into my little table. So I'm going to go ahead and add it in. So remember, tangent is sine over cosine. So basically what I'm going to do is just take the numerators. So this would be 1 over root 3. Root 2 over root 2 would just be 1. And then this bottom one would be root 3. So for part A, I'm seeing that it's positive. So that positive means I'm going to be looking in quadrant 1. And then according to my table, it looks like my reference is 30 degrees. So I need the angle in quadrant 1 with a reference of 30, and that just happens to be 30. Now in radians, that would be pi over 6. Then if we look at part B, so this one's asking for tangent inverse of 0, I see that it doesn't happen anywhere on my table, so that means I probably need to go to this version. Now remember, tangent is sine over cosine, so it's the y over the x. So in this case, it would be 0, undefined here, here it would be 0, and here it would be undefined. So technically there's 2 places, but be careful. It's only supposed to be between 1 and 4. So only 0 is going to be our answer. And that's just because of that interval that we're stuck in. So my answer here is going to be 0 degrees or 0 radians, whatever you prefer. And lastly, arctan -1. So that negative right there means that I'm in quadrant. You think about it. It's either 1 or 4. In this case, it'll be 4 because it's positive in 1, negative in 4. And you can even see that on the graph, right? Because it's positive above here, and that's quadrant 1, and then it's negative below here, and that's quadrant 4. And then my reference, if I look at my table, is 45 degrees. So I'm looking for the angle in quadrant 4 with a reference of 45 degrees. So for this, I would do 360 minus 45, which will give me 315. In radians, that's going to be 7 pi over 4. The way that I would get that is this is 0 or 2 pi. 2 pi can be written as 8 pi over 4. So if I subtract pi over 4, I get 7 pi over 4. I do want to also give you the intervals for the reciprocal functions. So let me write those for you. So for alpha equals cosecant inverse of some value, alpha is going to be in the interval negative pi over 2 to 0, union 0 to pi over 2. Really, it's just like sine. So you're right, you see the negative pi over 2 to pi over 2. It's just that there's a break in the middle of it at 0 because cosecant is undefined right there. Because you have to remember, cosecant is 1 over sine. Sine is 0 at 0. So if it's 1 over 0, you're getting an undefined value right there. So that's why you have to have that break in the interval. Same story for secant. It's very similar to cosine, but there's a break where cosine would equal 0, which happens at pi over 2. And cotangent is a little different. It actually looks a lot closer to cosine. So like tangent looked really close to sine, cotangent looks really close to cosine. So 0 to pi for that interval. And then lastly, I do want to show you um, one more type of example. And this one, I'm just going to do some different ones, kind of just make some up, honestly, and see how it goes. So I'll just say evaluate. I definitely want to do one of these reciprocal ones. So let's do cosecant, inverse, and let's do square root 2. And then let's do I'll do 2 of these type. Let's do cotangent inverse. We'll do negative square root 3. Let's do C. I might need some more space there actually. Let me write further down. C. I want to do some um, composition ones, so I'll show you what that looks like. We'll do arc sine parentheses cosine pi over 6. Part D, I'll do another composition one. Let's do cosine inverse, cosine, and 5 pi over 3. Yeah, okay, we'll start with these. I do want to rewrite my little chart, so give me a second to do that. I know I'm writing it kind of small, but I mean, I've written this thing so many times. If I want another function, I can write it over on the side. And then I'll draw this one as well. All of this is from going all the way back to 1.4. So if you remember in 1.4, I was like, if you don't know this, you will have a hard time doing anything else because I keep writing it. I keep needing it. All right, so let's start off with the first one, cosecant inverse root 2. Now let me remind you of something, that cosecant inverse is the opposite of sine. So what we want to think about, just for reference, is if we want to think about sine inverse, we want to think, where is this, right? This is technically over 1. Where is this 1 over root 2? Now be careful. 1 over root 2 is the same as root 2 over 2. So what I want you to think about for this one is, where is sine root 2 over 2? And that's going to happen at 45 degrees. So my reference here is 45 degrees. So sometimes just boiling these back to sine and cosine can be really helpful. But we do have to pick our quadrant. So cosecant is also quadrants 1 and 4. The only difference is that we can't include um, 0. But that's fine because we're not. This is a reference of 45. So if it's positive, that means it's going to be in quadrant 1, just like sine. So this answer is 45 degrees, or pi over 4. Now for my next one, cotangent. So it's negative, so be careful. Cotangent is from 0 to pi. So that's going to be quadrants 1 and quadrants 2. Everything's positive in quadrant 1, so it's going to be negative in quadrant 2. Also remember that cotangent is cosine over sine. So if I were to maybe add it into my table here, cosine over sine, so this would be root 3, 1 over root 3. So it's like the opposite of tangent. And so it's looking like that's happening at a reference of 30. So now I need to know, okay, I'm in quadrant 2, reference of 30. So what angle in quadrant 2 has a reference of 30? So if I do 180 minus 30, I get 150. If I want radians, I just need to use, this is pi over 6. This would be 6 pi over 6. So that angle would be 5 pi over 6. Because I would do 6 pi over 6 minus pi over 6. Just like I did 180 minus 30, I'm just using that subtraction. If I come down here, so these are composition ones. So these you actually have to just start from the inside and then work your way outwards. So start off with the inside, so cosine of pi over 6. So remember pi over 6 is technically 30 degrees. So I'm coming over here to my table. Cosine of 30, okay, it's square root 3 over 2. So this becomes arcsine square root 3 over 2. So then I come back to my table. I say, okay, well now I'm looking at sine square root 3 over 2. Okay, that's 60. So my reference is 60. It was positive. So is it quadrant 1 or quadrant 4? Quadrant 1. So 60 degrees. Now, because this one started you off with an angle in radians, it's likely they want radians back. So this would be pi over 3 in radians. Again, I don't really mind. Radians are degrees. It's fine. The only reason I'm writing both for you on the notes is just so you have the experience of seeing both. I do not need both. You just pick one for me. And for our last one, I might write more though. So cosine 5 pi over 3. So I want to start in the inside and then work my way out. So cosine 5 pi over 3, let's see what that is. So this would be 6 pi over 3. This would be 3 pi over 3. So it'll be closer over here. So it's going to be 5 pi over 3. Has a reference of pi over 3, or 60 degrees. So cosine of 60, I'm looking at my table to get that, is 1 over 2. So this becomes cosine inverse 1 over 2. Now we have to check, it's in quadrant 4, so should it have been positive or negative? Cosine is positive in quadrant 4, so it'll stay positive. But that would be something you want to be careful about there. Now we do cosine inverse of a half. So because it's positive, that means I want an angle in quadrant 1. My reference is 60. So my answer here is 60 degrees, or pi over 3. So, of course, be careful. Sometimes I get students kind of think that these just cancel out. Not necessarily. Sometimes that can happen, but it's only sometimes. So, you don't really want to get into this idea of like worrying about when it's okay to do that and when it's not okay to do that. It's going to feel like too much to remember. Just work your way inside and then work your way out. I kind of want to make up some more of these. Let me go check out the homework too. I just forget what's on there. But I have it pulled up. So I'm going to go ahead and take a look real quick just to see if there's any more that maybe I would want to do that are similar to problems on here. Just going to pick a random one. Oh, that looks like what we've done. Yeah, they all pretty much look like what we've done. So I feel pretty good about it. There's maybe some hard ones at the end, and I'll do one like that. Actually, now that I see it in there. I forget because in 240 we do some harder ones, and I forget that they are also happen to be in trig because it's like we won't really test on some of the harder ones, but because it's an online class, I really do want to make sure that I show like as many examples as I can. So let's go ahead and I want to do maybe two more of these, like of the composition ones. Um, let's do one that involves like tangent maybe. So let's say tangent, uh, sine inverse, and let's do negative square root 3 over 2. Yeah, sure. You're probably like, I don't know, is that what you want to do? I'm thinking. And then maybe one more. Let's do sine, arc sine, root 2 over 2. Maybe let's make it negative. It's just hard because these, like, there's really not that many that I can give, to be honest with you. You know, like, we only have 3 reference angles. It's either square root 3 over 2 as the answer, or, you know, as like the value from the table. It's either square root 3 over 2, root 2 over 2, or 1 over 2. And then I can make it negative or positive. So it's not like I really have that many options. So tangent, sine inverse, negative root 3 over 2. So we always start from the inside, work our way out. So negative here is going to mean that I'm in quadrant 1 or quadrant 4 for sine. So this is going to be quadrant 4. My reference, if I go check out my table, it'll be 60 degrees. So I'm looking for the angle in quadrant 4 with a reference of 60. So that's going to be 300. So then I'm doing tangent of 300 degrees. And so again, 300 has a reference of 60. So if I go to my table, I have cotangent in there right now, but I could always write in tangent. So this would be 1 over root 3. This would be 1. This would be root 3. So tangent of 60 is root 3. But we got to figure out positive or negative. Quadrant 4, tangent should be negative. Now, if you forget like which ones are positive and negative and what quadrants, we talk about that in 1.4. And I use like the little thing of all students take courses. And so this is all are positive, sine is positive, tangent is positive, cosine is positive. So going back to that is how I figure out positive or negative. Next, arc sine negative root 2 over 2. So again, negative is going to mean that I'm in quadrant 4. I have a reference of 45 degrees. Quadrant 4, 45 degrees, is going to be 315. I would get that by doing 360 minus 45, so that's 315. So then I'm looking for sine of 315. And it's negative in quadrant 4, reference of 45, so root 2 over 2. So that one, like, technically they like cancel out, but I would just be careful doing that because, like, you know, part D, it had cosine and cosine inverse, but they didn't cancel out, you know, they didn't end up as the inside angle. So just be careful. I don't recommend ever trying to cancel out. I recommend, I'm putting quotations around that as if you can see me, but I always recommend just working your way, starting in the inside, working your way out. So the last type that I want to look at is something from the homework that I do think would be good to check out. So this one says, find the equivalent algebraic expression for the composition below. And it says sine arc secant x. I actually love these. You may not, but I do. But I do. And there are some on the homework as well that might ask you to like use a calculator or something. Um, of course, on the test, I try to never make you use a calculator. So there's only one exception, and it's some stuff in chapter 5, which is going to be on test 3. That's the only time like you need a calculator. So for this one, kind of interesting, you still start from the inside. And so this one, like the answer is not going to be a number. It's going to be like an algebraic expression. So it's going to have like x in it. So arc secant of x. Be careful of what that's telling you. So remember, arc secant of something is supposed to equal an angle. So I'm just going to say alpha. And I know that because that's always, you know, all the arc, all the inverses, they all should equal an angle. Now, if I rewrite this as secant of that angle should be equal to x. So instead of writing it as the inverse function, I'm writing it like backwards, like the original functions that we saw. Now remember that secant has a connection to a triangle. So secant is supposed to be equal to hypotenuse over adjacent. Well, I don't see a denominator. However, if you don't see one, that means that it's just 1. So I can actually make a triangle out of this. So I can say, okay, my angle's alpha, my hypotenuse is x, my adjacent side is 1. Now let me show you as well why we're doing this. So when we let arcsecant equal some angle, if we replace that, we just get sine of the angle. So that's pretty much all I'm looking for, is I'm looking for sine of this angle alpha. Well, sine is opposite over hypotenuse. I already know the hypotenuse is x. I just need to find the opposite side. So to do that, I'm going to use Pythagorean theorem. So I'm going to call this side A temporarily. And we'll say 1 squared plus a squared equals x squared. I'm solving for a. So I get a squared equals x squared minus 1, because 1 squared is just 1. And then if I take the square root, I get square root x squared minus 1. So at the top here, we square root x squared minus 1. And that's it. So pretty much just using triangles, but it's a little bit different of a way of thinking. This is a problem that, for those of you who are going to go to 240, I love this problem. I love asking it. I do find it fun to show it to y'all. It's like puzzly. So I believe that that's it. I'm clicking around the homework a little bit real quick. Some of these you're going to be asked to do in the calculator, so I don't really feel the need to like look at those, but yeah. If you do have any questions, of course, please let me know. This is it for this section, and then our next video will be over 4.2. So I will see y'all in the next video. Bye-bye.